In this video, we're going to work through a complex Kirchoff law problem. So here we have a diagram that shows a circuit containing two batteries, a 5-volt one there and epsilon here, three resistors, a 4 ohm, an 8 ohm and a 2 ohm, and an ammeter which has negligible resistance, which is sitting here, and the ammeter is reading 0.75 amps. We're going to calculate the current I1, the current I2, and work out what the EMF voltage is across the second battery set. Okay, so let's look at the solution for I1. Okay, so basically we're going to apply the loop rule, which is basically the voltage rule that we learned earlier. Basically what this means that we're going to go from A to B to C to D back to A again. And remember, the voltage loop must equal 0. So if we look at the 4 ohms resistor first, we notice that we've got a voltage going across here, which can be calculated using the Ohm's law. It's going with the current, so as a result it's coming out. We've got a current of 0.75 amps and a resistance of 4, so that's negative 3 volts coming out. If we follow the 2 ohm resistor, again it's coming out, following the current, so we get a negative voltage. We know that we've got I1 because we don't know the current in this case, and we've got 2 ohms. So that basically gives us negative 2I1. If we look at the 5-volt battery, we know that it's running in the opposite direction, so it's like going uphill, so we are adding in 5 volts of energy. Thus, combining these together, we get negative 3 volts minus I1 times 2 plus 5 volts, all equals 0. Remembering a voltage loop always must come up with 0. So rearranging this, we get I1 equals 1 amp. So let's look at solution B. In this case, we're going to work out the current for I2. Now, in order to do this, we have to apply the junction or current rule. Basically, this rule states what comes in is equal to what comes out. So we're following I1 going through, which we know is 1 amp. We know that we've got 0.75 coming off, and we're going to find out what I2 is. So I1 equals I2 plus 0.75. So I know that I1 equals 1, so I2 plus 7.5 rearranged will basically give me 0.25 amps. So now let's follow on and find the solution to C, which is to find the EMF for the second battery. So again, we're going to apply the loop rule or the voltage rule, but we're going to go B to C to F to E back to B again. So basically what I'm going to do is work out what I've got for each portion of the loop using the resistance formula, V equals IR. So going from B to C, I've got negative 0.75 times 4, which equals negative 3 volts because it's going with the flow. Now I come down, going from C to F, and I'm going through the 8 ohm resistor. So basically I'm going against the flow, so I add this in, and I know I've got 0.25 coming in. So 8 times 0.25 gives me 2 volts. Now I'm going to work out what going from F to E. Now this is going uphill, so I make a positive result, and I've got nothing going EB. So combining it all together, I get negative 3 volts plus 2 volts plus epsilon, and rearranging, epsilon will come out as 1 volt. And that's it solved. Thanks for watching.